Alright, we're going to look at Algebra 2, Unit 3, adding and subtracting rational expressions. Adding and subtracting rational expressions is very similar to just adding and subtracting regular fractions. The concept is the same. We need a common denominator, and once we have a common denominator, we'll just add or subtract the numerators. This may go a little fast, so you may need to pause if I get ahead of you a little bit. So let's go ahead and look at this example 1. We have 2x over x plus 3 plus 6 over x plus 3, and we have the same denominator, so we're going to go ahead and add the numerators. And they are unlike terms, so they do not combine. But once we put them together, we notice that the numerator factors, both terms in the top, are divisible by 2. We get 2 times the quantity x plus 3 all over x plus 3. And we find that those two factors reduce. And our final answer is just 2. So that is relatively uncommon with rational expressions, but definitely happens. So let's get example 2. So we notice in example 2 that we have the same denominator again, so we're going to add and subtract the numerator. When I see this subtraction here, we are subtracting the whole numerator in the second expression. So instead of having a subtraction there, I'm going to change that subtraction to adding the opposite. So this minus becomes a plus, and I'm going to change the signs after it. So now when I add my numerators, I'm going to get 2x, 3x plus negative 2x and get x, 4 plus 5 and get 9, and my denominator stays the same, x minus 7. Nothing reduces, so that one is finished. Alright, so those are fairly straightforward examples. These become more difficult when we have different denominators and we need to find the LCD. The LCD of a rational expression, I like to think of it as the unique factors with their highest exponents. So the unique factors of the denominator with their highest exponents. With the highest is what that word says. Exponent. With the highest exponent. So this is kind of a weird thing, but this is how I think of it. So the LCD is the unique factors of the denominators with the highest exponent. So that comes into play when we look at this first example, and we see that there's only one factor in the denominator, and that factor is x, but the highest power there is x to the third. And the reason we need the highest power is because we're going to have to get these to have the same denominator, and I think you can see it. I hope you can see it's easier to change this x into an x to the third, and it's much harder to make the x to the third go down to be an x to the first power. So that's why we need the highest power. If we look at the second example, we have one factor of x minus 2, and we have one factor that is just x, with the highest power of that x in the denominator. It's the highest power in the denominator is squared. So the unique factors are x and x minus 2, the unique factors of the denominator, and the highest power of the x factor is x squared. In the third example, we've got one factor of x, we've got one factor of x minus 3, and then this middle term, the denominator factors to factors to x times x minus 3. So I won't repeat those factors even though they're in different denominators. I want the unique ones. I want to show each factor once, but show it with its highest exponent that's present. So the x factor is there, and then the other factor is x minus 3, and they're all to the power of 1. So this first one is x minus 3 to the first. The second one has x to the first, x minus 3 to the first. The last thing is just x to the first. So the unique factors are x and x minus 3. Their highest powers are 1. So when we want to add or subtract denominator, or add or subtract rational expressions, we need to get a common denominator. Common denominator, kind of sloppy, denominator, but that'll be pretty clear as we go through. And then we're going to multiply each term, and I'd like to think about multiplying each term by 1, and again this is kind of weird, but I think it'll make sense as we go through. Multiply each term by 1 to get the common denominator. So what will this look like? If you wanted to make a list of it, I'll do my best over here. Write it down for you. So your first step is to find the LCD. Find the LCD. The second step is to multiply each term. And you're going to multiply the numerator and denominator. Multiply each term. So that every term has the LCD. Every rational expression has the LCD. Then you're going to add or subtract the numerators, assuming the denominators are the same. And simplify. Okay, simplify / reduce. Okay, so sorry that's pretty sloppy. Steps don't always make sense until we've done a couple examples. Alright, so if you want to pause it to finish writing that down, you can read my hieroglyphics. Going on, if we look at this first example, we have two different denominators, so we're not ready to add. The LCD is the unique factors of the denominator with their highest exponent. So one factor is x, the other factor is x plus 2. So the unique factors are x and x plus 2. What we see is that the first term is missing the x plus 2 factor. So when I said we have to multiply terms by 1, what we're going to do is we're going to multiply both the top and the bottom of that first term by x plus 2. So this thing in the orange, x plus 2 over x plus 2 equals 1, and this will get multiplied by the first term. And the second term is missing the x, so I'm going to multiply top and bottom in the second term by x. So this thing that I'm writing in green is equal to 1. So this is 1, and this is equal to 1. So I haven't changed either term there in terms of its value. So now I need to go ahead and multiply, distribute the 3, and I'll get 3x plus 6 all over x times x plus 2. I like to leave the denominators in factored form. There might be different teachers that expect different things. Distribute the other factor n on the second term, x squared minus 5x all over x times x plus 2. And now we have a common denominator, so we can add or subtract the numerator. And we're going to get x squared. We've got a minus 5 and a plus 3, so we're going to get minus 2x plus 6. And x squared minus 2x plus 6 does not factor. So that we'll just leave it the way it is, and we get x over x plus 2, and I leave that in factored form, although different teachers will ask for different things. And there's your final answer. All right, if you need to pause, go ahead and pause now and move on to the next example. All right, example 4. Here's the LCD. The first term factors to 10 and an x. The second term factors out a 5 and an x and x minus 2. Now 10 has a factor of 5 and 2, so this 5 here is contained within the 10. So we won't need to, it's actually not unique, it's in the 10, so we're going to have 10 as our LCD. We're going to have x with its highest exponent, so x squared as a part of our LCD. And the last factor is going to be this x minus 2, which is going to be part of our LCD. So our LCD is 10x squared x minus 2. I think I'm going to need this room here, sorry. So the first term is missing the x minus 2, so I'm going to multiply top and bottom by x minus 2 over x minus 2. And that gets multiplied by the 3 over 10x squared. The second term, and I erased the factored form, but I hope you remember, I'll rewrite it. It was 5x times x minus 2. So it's just missing a 2 factor. It's missing a 2x, sorry. Missing a 2x. So we're going to multiply top and bottom by 2x. And I'm going to distribute this. Alright, so we multiply this through, and we're going to get 3x minus 6 all over 10x squared times the quantity x minus 2 plus 4x squared. And we know we're going to have the LCD, so we can go ahead and write this in factored form. 10x squared times the quantity x minus 2. Now I'm going to add my numerators. I get 4x squared plus 3x minus 6 all over